So we are now interested in designing a Mealy machine. Okay. So what is the problem? The problem is design Mealy machine which accepts the language having strings ends with 00 or 11. Okay. So now this is just like a finite automata. Okay. So if it could be a finite automata which accepts the language having strings ends with 00 or 11, then with the help of final states, we could show that it is acceptable or not. But here we don't have final state. So here with the help of output symbol, we have to indicate whether the given input is acceptable, is ending with 00 or 11. Is it clear? So what is our problem now? Our problem is we want to design. So we want again the same thing. What we want? We want that machine to be designed which is having 6 tuples: Q, input alphabet, output alphabet, delta, lambda, and Q0. Right? So here what is clear to us? The clear is input is what? It will be having 0, 1. From this, it is clear. We can have input which is having two symbols 0 and 1. What about delta? So here, delta will be, we want to say that whether the given input is having, ending with 0, 0 or 1, 1, yes or no. So I can say we can have the output as yes, no. Okay. So these two things are over. Which one? This and this. Now we need to find out the another 4 things, right? Now how to think? So how many states will be there? Which will be the initial state? So now here, if my string is 0, 0, I should get output as Y. Okay. If my input is 1, 1, then also I should get output as Y. If I have this kind of input, then also I want output as Y, right? But if I have input something like this, then it should give me no, right? No. Then 1, 0, 1. Then also I should get no. Okay. So I can make here one initial state. The same diagram can be useful to design the finite automata. Okay. So now I can use any name of state, but I'm using here name of state as it is shown or given in the book. Okay. But it is not necessary you should use same names. So they have written here, for example, P state. Okay. So here ending with 0, 0. So how many states will be required? So 0 and ending with 0, 0 means what? I need a state where if I have any number of 0 ones, I get 1, 0. And then if I have any number of zeros, right, then it will be acceptable. For example, 0, 0, acceptable, 0, 0, 0, ending with 0, 0. Ending with, so again it is ending with what? 0, 0. So first 0 is necessary. Next 0 can be taken care by this self loop. So remember this designing technique. Okay. First 0 you are moving to this state. And since these two are same, right? So you can have your self loop, right? Similarly, I can have this, there is a OR. Remember this, there is a OR, not a AND. So either ending with 0, 0 or ending with 1, 1. So whenever there is a OR, you should always have two parallel paths. Okay. Like this. So I can write here Q1. Okay. And 1 and just like same, I can have here 1. So this is a very first step. 0, 0, 0, 0 ending with 0, 0. 1, 1, 1, 1, 1, 1, ending with double 1. So this will be, even if you will draw this much, you will get some marks. Okay. Now, suppose we get, so here, when I will get here output as yes, if I am moving only, or if I am getting input as only 0. Okay. What is the output expected? Now, this is not a Murray machine. The output is not associated with the states. The output is associated with the current state as well as current input. So, my state is P, my input is 0. So, with the P, current state P, input 0, I am moving to Q0. But what about the output? So, this 0, if this is a input string, my machine should give me answer as no. This is not ending with double 0. Okay, so if I get a single 0, I should give output as no. Is it clear? But once I go here and there is at least one single 0 occurrence, then my output will be yes. Same way, if I get only single one, my output will be no. But if I get one more one, then my output will be yes. So my output are dependent on the current state and input symbol. Okay. Next, what if I get, for example, this, if I get 0 and then 1, we know that output is expected to be no. So if I get 0 and I don't get 0, but I get 1. So I should reach to a state, okay, where this Q1 is indicating what? Here I have got first 1. This indication is what? I have got single 0, right? So after this 0, if I get 1, then there is a chance that I can get one more number of 1 and then it could be a yes. It may be ending with 1. So if I get 0 and 1, output expected is no. And I am reaching to a state Q1 because this is the indicator of getting at the end first 1. Okay. And if you get any number of 1, like 0, 1 and 1, you will get output as yes. Similarly, there will be another transition from Q1. So if I get this one, 1, 0. So 1, I am reaching here. And with the 0, I am moving to a state where is it just like it is the first 0 from backside, okay, ending with. So here this transition will be 0. And what is the output? 1, 0 is not acceptable. So I'll write here no. Okay. So can I say now for every state, I have considered 0 and 1 transition. See, P on 0 moves to Q0. P on 1 moves to Q1, Q0 on 0 moves to itself, Q0 on 1 moves to Q1, Q1 on 0 moves to Q0, and Q1 on 1 moves to itself. So this is my designing of the Mealy machine, which is showing me or giving me information whether given string is acceptable or not. Is it clear? Now we will draw two tables. Which two tables? First table is our delta function, that is STF. So here Q summation, what is the input? 0, 1. Right? Now, how many states are there? P, Q0, Q1. Which is the initial state? P is a initial state. Right? Now show the transitions here. So this is my delta function. Right? P on 0 moves to Q0. P on 1 moves to Q1. Q0 on 0 moves to Q0. Q0 on 1 moves to Q1. Q1 on 0 moves to Q0. And Q1 on 1 moves to itself. So this will be my delta function for designed Mealy machine. Now what will be my lambda function? my lambda function will also have how many columns? So I cannot combine here as we can do in Mealy machine, right? So here I need to have two columns for input alphabet, 3-state P0, Q0, Q1, initial state. Now, what is the output? P on 0, okay, produces output no. P on 1 produces output no. Next, Q0 on 0 produces output yes. Q0 on 1 produces output no. Next, Q1 on 0 produces output no. And Q1 on 1 produces output yes. So this is my lambda function. Okay. So can I say now I have designed my Mealy machine? So what is required for designing Mealy machine? Had we finalized Q? Yes. How many states are there? 3 states. P, Q0, Q1. Right? So we have defined now Q. Have we defined delta function? Just now we have completed. Lambda function is defined. What about P, Q0? It is a initial state. So here I can say my Q0 is nothing but in my diagram, it is P, initial state, right? So in this way, I have designed the Mealy machine. Is it clear? So in Mealy machine, the output is dependent on what? State and the current input. Now, whenever you are asked to designing, so not only you have to complete these two tables, but you have to simulate it. Okay, so how you will simulate? So you will be writing current state, then current input, okay, then next state and the output. So if I have been given, so for one sample, I need to represent it. So suppose my input is 1, 0, 1. This is my input. I want to test. Okay. So my current state will be initially P. And now my current state is now P, right? Now my current input is what? Here, very first I need to take 1. So P, see here, P on 1 moves to Q1. Next state is Q1. What about output? My output is P on 1 produces output no. Is it? Right? Next. Now this Q1 is acting as my current state. What is my current input? 0. Now Q1 on 0 goes to Q0 and Q1 on 0 produces output no. Next, now this Q0 is acting as my current state. My input is now 1, right? So Q0 on 1 moves to Q1, right? Q0 on 1 moves to or gives output no. Have I read whole string 101? Now what is my output here? My output is, that is, last output is no. So this indicates the given string 101 is not ending with either 00 or 1, 1. Clear? So in this way, another way is you should write here P on 1 moves to Q1. Okay. And the output is P on 1 moves to Q1 and P on 1 gives you output no. Q1 on 0, Q1 on 0, Q1 on 0, Q1 on 0 goes to Q0, right? And what output it is producing? On 0, Q1 on 0 is producing no output. Similarly, now Q0 on 1. Q0 on 1 goes to Q1 and Q0 on 1, Q0 on 1 gives you output no. So here, for as many input symbols, okay, that many output you will receive, and the last output is indicating your expected output. But when we are, what is the time?